voltmeter here. Whoops, not where I wanted it. Here and here. What will the voltage read on the voltmeter? Why would that be 12?
Because you're closing the gap.
Okay, we just closed the gap that we found out was open here with the voltmeter. The electricity tries to go through the voltmeter because at this point we now have that voltmeter connected in series with the rest of the circuit.
Yeah, but if your bulb's no good, it's not going to read 12.
You're right. If the bulb is no good, it will not read 12. So let's say the bulb is good for just a moment.
Okay.
And then we'll take it so it isn't good and see what happens. Good thought. Right now, the electricity then can flow through the light. We found out that it couldn't flow through here, wouldn't work. The electricity then tries to flow up here through the voltmeter and into the battery post to turn on the light. Will the light turn on?
No.
Why?
Electricity don't go through the voltmeter.
Okay. We say that tongue-in-cheek, remember. The electricity doesn't go through. Current flow will not flow through the voltmeter to turn on the light. So this will read 12 volts. We know we have an open circuit between this post and this cable.
Right.
Now, as Ted just mentioned, if this light is burned out, there's two open circuits. Two reasons that the circuit isn't working. And this will make you then do a little more scratching to find the problem. Because if we put a voltmeter here, it probably, well, if it's totally open, it'll read 0. I'll come back to the illustration again. Let's have another scenario here in just a second. The same thing. So we'll remember we had to have one. And we put the voltmeter here with an open circuit in the bulb. Because electricity cannot flow through this circuit at all, then the meter will still read 0. Electricity tries to come up here, it can't get through the light, comes down, can't come down here, can't go through here because this is open and this is open. So really what you've done is got a piece of wire hanging out in midair and you connected the voltmeter to it. Obviously it's not going to read anything. Okay? So when you're troubleshooting then, you say, well, I found there was no circuit here. If this light is burned out, you have 0 here. How do you know that's an open circuit then? In this test right here.
When you first check the bulb.
No. You took your voltmeter and you placed it, originally we placed it right here, remember?
Okay.
We had 12 on the battery post, and then we moved it over to here, and we had 0. The light's burned out, but you don't know that yet. So how can you know that that has an open circuit right here?
Well, because you're not getting a good connection on your post, and it's not giving you a reading.
Okay, because this is not connected to this post. So you found out that's open, even though you don't know the light bulb's bad. There could be two problems. You still found out you do have an open here. And when you put it here, because you know you had an open here, and you got 0, then that tells you you have an open someplace else in the circuit. So now then you have to go through your current being applied or voltage being applied to a circuit to find out where the problem is. So then we would connect the voltmeter to the negative post. We already connected it to the positive post and found we had voltage. We can connect it to the wire coming off the positive post and make sure that the connection is good there. And we read 12 volts. So we know this connection is good. We've already found out this connection right here is bad. Right? we move on up with our voltmeter from there up to the base of the light. What should the voltage read? Okay, it'd be 12 here. Now, if we move the voltmeter from there to here, we already found out we had a bad connection here. What would the voltage read here?
0.
Well,
Bulb is,
It
bulb
depends.
is gone.
Bulb's gonna be 12 volts.
Okay, if the bulb is good,
Yeah.
it will read 12, and Parker said if the bulb is bad, it will read 0. Because the electricity cannot flow through this resistor to this side of the light bulb. If the circuit was good, the light would be on, wouldn't it?
Right.
If we got a problem, we know there's a problem, that's why we're testing it. So now we have 0, we know we have a bad light bulb, we replace it, the light still doesn't come on. Because you have a bad circuit down here that you've already found. If you put the light in, this would become 12 volts now, and obviously you'd have to go down and correct this problem. As soon as you correct this problem right here, the light will come on. The other scenario that we wanted to talk about, we said we had a relative, well, I'm not going to tell you what we have. We have a series circuit, a simple circuit. Connect the voltmeter to the battery post, we have 12 volts. And the light does not function. We connect the voltmeter from there to this wire. It reads 0. If we connect, I need to reverse that. Let's say this reads 12. We went through that other. It reads 12. System still isn't functioning. And we come up to this point with the voltmeter. And it reads 12. What does that tell us?
Got a bad connection when your bulb, between your bulb and your socket. Not getting a good
No, we
connection.
got an open somewhere between the end of the wire of the light bulb to the your post.
Well, if you had a bad connection between the two wires, then you would get 12 volts up to the bulb. See what I'm saying?
Yeah, but the voltmeter close to the out there.
No, look at it close. We're not connected in series with the voltmeter there. If we read 12 here, we have a potential at that point, and it should work. The light's burned out. Or a bad connection, what you just said. Okay? Either the light's burned out, we do have potential here.
Yeah.
Okay, let's say that I take that light bulb and I twist it around a little bit, and the voltage goes to 0. What did we just discover?
Bad connection.
We had a bad connection. Now, what happens if, will the light come on now?
That's good, it should.
Okay, if the light is good, the light will come on. This went to 0, the light will turn on.
Oh, no, not the bulb going to 0.
The volts go to 0 here.
Your light won't come on, it's lost all power.
Is that right?
Yeah. Got nothing to fire the bulb.
Okay. If we lose voltage here, we have no potential.
Right.
Without potential, it won't work. So what happened? Something happened when we wiggled the bulb around. The voltage went from 12, which means we had electricity there, But now, we've wiggled it and made a good connection, it's gone to 0, and it still doesn't work.
Open circuit.
It's still on the circuit somewhere.
Okay, you have an open circuit somewhere. Now you've got to find out where, right? Well, let's go back to our meter again. If we had a meter here connected up, we had two of them, we'll say, we would have found then that this meter goes to 0. What does that tell you? You got bad connection on the post. Okay, then why did it give me 12 volts in the first place?
You had a good connection until you wiggled your wire and lost all its connection.
But I didn't wiggle anything down here, so why did it change?
Because you got the open circuit up by your light bulb.
I had one. When I wiggle it, it's good. That's why it went to 0. This is the same thing that happens every time you hit your starter motor and the battery cable poster is not clean.
Low voltage.
Was there a load on here when the light was not making contact?
Not there.
See, when we put the voltmeter here and got the 12 volts, there was no load up here because this circuit was open. If there's no load, there's no voltage drop.
Can you put a
You
load
see, I
up?
just keep going over that time and time again because in different scenarios you forget it. You've got to remember that. When there is no load, there is no voltage drop. Even though this connection right here is not good, voltage may get through it. It's not totally open because there's no load on there. That's going to trip you guys up time and time again if you don't remember that. As soon as we put the load on it, this circuit broke. It opened electrically. That happens many times. When you hit the starter, you put the load on the starter, which is the same as putting the load with this light bulb, and it cranks and quits. It may click and quit. It may crank a little bit and quit. It may not do anything because you have an open circuit, and that's where you get your voltmeter and you go out and find it. The easiest way to do that if you're alone, as soon as that happens, turn on your headlights because that's a load, right?
Yeah.
You can't hold your starter on very good and go out under the hood unless you hook up a remote control starter switch. And sometimes you have to do that. The easiest thing though is turn on your headlights. You've got a load. Now put your voltmeter on the positive post and the negative post of the battery. We read there 12 volts. We move over to the cable and we read 0 because you open that circuit because there's a load on that circuit. It'll break it open. You know you've got a problem. Correct that